reading of 5 or more amps on a bare ground wire running from the panel board to the water pipe indicates a ground fault. Several potential causes need investigation. Firstly, a faulty neutral wire could be the culprit. A break or damage in the neutral wire can allow current to flow through the grounding system. Secondly, reverse polarity can create this situation. If the hot and neutral wires are swapped, it can create a situation where current flows through the ground wire. Thirdly, an overloaded circuit might be the cause. Excessive current demand on a circuit can cause the voltage to drop, resulting in current flowing through the ground wire. Fourthly, damaged insulation or wires can allow current to leak to the ground. Worn or damaged insulation or wires can allow current to leak to the ground. Fifthly, corrosion or water ingress can be a problem. Water leaking into electrical components can cause corrosion and allow current to flow through the grounding system. Sixthly, improper grounding connections could be the reason. Loose or improperly installed grounding connections can prevent proper grounding and allow current to flow through the bare ground. Troubleshooting these issues requires a systematic approach. Firstly, verify the wiring. Check the neutral wire, hot wire, and grounding wires to ensure they are properly connected and not damaged. Secondly, test the polarity. Use a multimeter to verify that the polarity is correct, with the hot wire connected to the hot terminal and the neutral wire connected to the neutral terminal. Thirdly, check the circuit load. Determine if the circuit is overloaded by adding up the amperage of all devices connected to it. Consider reducing the load or upgrading the circuit if necessary. Fourthly, inspect the insulation and wires. Inspect all electrical components for visible damage or worn insulation. Replace or repair any damaged wires. Fifthly, check for water ingress. Look for signs of water leakage in electrical boxes or near water sources. Fix any leaks and dry out the components. Sixthly, tighten the grounding connections. Ensure that all grounding connections are securely tightened. Use anti-corrosion compound on grounding rods or clamps to prevent future issues. To elaborate on a faulty neutral wire, consider that the neutral wire is intended to carry the return current from electrical devices back to the source. If this wire is broken or has a high resistance connection, the current may find an alternative path back to the source, often through the grounding system. This is dangerous because the grounding system is not designed to carry continuous current. It's only meant to provide a path for fault current in the event of a short circuit. Regarding reverse polarity, this occurs when the hot and neutral wires are inadvertently switched at an outlet or within the electrical panel. This can energize the appliance chassis or other grounded parts, creating a shock hazard. In an overloaded circuit scenario, the excessive current draw can cause the voltage to drop, which in turn can cause current to flow through the grounding system as it seeks the path of least resistance back to the source. This situation can also overheat wires and potentially cause a fire. When inspecting for damaged insulation or wires, pay close attention to areas where wires pass through metal boxes or are exposed to physical stress. Rodent damage can also be a common cause of insulation failure. Water ingress can create a conductive path between energized components and the grounding system. Even a small amount of moisture can significantly reduce the insulation resistance and allow current to flow. Finally, proper grounding connections are critical for ensuring that fault current can quickly and safely return to the source, tripping a circuit breaker or fuse and energizing the circuit. Loose or corroded connections can impede this flow and create a dangerous situation. When checking for water ingress, also inspect the service entrance where the main electrical lines enter the building. This area is often susceptible to water leaks. When tightening grounding connections, be sure to use the appropriate tools and torque specifications. Over-tightening can damage the connections, while under-tightening can lead to loose connections. In addition to these steps, it's important to use a calibrated multimeter to accurately measure the current flowing on the grounding wire. A clamp meter is particularly useful for this purpose as it allows you to measure the current without disconnecting the wire. If you are not comfortable working with electricity, it's best to call a qualified electrician to diagnose and repair the problem. Electricity can be dangerous, and it's important to take all necessary safety precautions. Before beginning any electrical work, always turn off the power to the circuit at the main electrical panel. Use a voltage tester to verify that the power is off before touching any wires. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Follow all applicable electrical codes and regulations. If you suspect a ground fault, it's important to address it immediately. A ground fault can create a shock hazard, damage electrical equipment, and potentially cause a fire. Do not ignore the problem or attempt to cover it up. Take the necessary steps to identify and correct the cause of the ground fault. Remember that the grounding system is a critical safety feature of your electrical system. It's designed to protect you and your property from electrical hazards. By properly maintaining your grounding system, you can help ensure that your electrical system is safe and reliable. If the current in the ground wire persists after performing these checks, a more thorough investigation may be required, potentially involving an electrician with specialized equipment to trace the source of the fault. Remember, safety is paramount when dealing with electrical systems.